All right, since everyone's here, everyone's excited to be here, so let's go in class.
Yes.
Okay, so now everyone's going to be paying full attention right here because these are important. Es muy importante. Now, as we go over this problem, I'm telling you this is probably, we're only going to end up doing this one problem today. I can't remember what the next example is, but this one right here, it has multiple things. So we're going to take time and please ask questions as we're going over it because there is a little bit more complication. Rectangular swimming pool, 10 meters long, 5 meters wide, has a depth of 3 at one end, 1 at the other end. Okay, so I'm going to start by drawing the cross section. My cross section is going to be 5 wide, 3 meters, 1 meter.
How do you know which side is what? No, but I mean, it would matter, or would it matter depending on whether it was the.
In that case, the slope would just be either side of the pond.
So
No, it's not.
let's start with the rectangle. Okay, it's a swimming pool, isn't it?
Yes.
So that would be a volume, length with height, right?
No, I mean, what side should. Okay, would the side that's 5 meters be the one that has 1 and then 3? Or would it be 10 with the 1 and then 3? It doesn't say. I don't know.
Oh, okay, yeah.
Does it not matter?
It's not gonna matter where.
So it wouldn't affect the volume?
You have a good question here. I'm like, okay, 10 long, so that's the long side.
Yeah.
So that's the longer side right there, and 5 wide. So in that case, that's going to be not the longest side, but that's like right here. Does that make better sense right there? The 10 long. So that's like.
So you would assume that one end of the pool and the other end of the pool would be the ones that are farthest from each other? And that's the ones that you would use for the 3 and then the 1?
Because, I mean, if we switch the values around like she's saying.
It is going to affect it. So let me.
Yeah.
So let me see here.
For a pool, typically the longer side is like shorter.
Yeah. So that is the deep part, right?
Yeah,
The deep end. So that's why it's 10 way over there.
And 5.
So yeah, if it's like this, it is 10 by 5 going this way.
Okay, and then the 5 would have
The 5 over here, so this is going to be the shallow end. Over here, this is the deep end.
Okay.
Make sense? Yes? So it's 10 long. My drawing is not to proportion, so I apologize. Okay. So drawing it is key. For a lot of these things that we do these problems, drawing something so you can start adding values to it so you can see from there. If water is pumped into the pool at a rate of 300 liters per minute. Okay, what is that say? 300 liters per minute. What is that? What does that represent? What? Okay, but thinking about my different formulas, what formula would I have that for? Volume. So it's a change in volume over time, right? So that right there tells me that would be a change in volume over change in time. That's 300 liters per minute. There you go. Let's see. At what rate is the water level rising when it is 1.5 meters deep at the end? So water level rising. Water level rising, that's a change in what? We're talking about a pool, right? And as we fill up the pool, it's going to go up here. So this is 1.5, so it's here. So it would end up becoming like right here. Huh?
Any area? Or
Not area. It's not volume. It's height. It is going to be height. Now, this is the reason why I gave you guys flashcards the other day. Anyone go and actually practice those flashcards again? Nope, completely forgot about it. So, this shape that we have right here. What shape is that? The black one. One more time. Yes, it is a trapezoid. It is a trapezoid. So in this one right here, I have a trapezoid, so I can find the area of that piece, but I don't need to find the whole area. I just need to find a part. The part that I'm looking for is this. Let me get rid of. I need to find this right here. Because it's asking for the height, okay, when it is 1.5 meters, so H is 1.5 meters. At what rate is the water level rising? So I have an H, but I am looking for, what's my end result? What am I looking for? Okay, but how would I write it? What's my notation for that? dH dt. The change in the height over time. So I'm looking for dH dt, and I have the volume. I have a volume formula, right? So I have a volume formula here, and that's going to be super important. So that means that I have to start off with a volume equation. Now, we have to be able to make a volume equation out of this. And that's why I mentioned about the trapezoid. My trapezoid is right here. Do you guys remember the formula for a trapezoid? Did it really just transfer over to the next page? Yeah. Okay. So trapezoid formula. Don't worry, I can wait, you guys. Mm-hmm. Okay, give me a formula.
Of the just trapezoid? That'd be like, well, if you split it into two.
It was on the cards that I gave you.
A plus 2.
And it's one that I actually gave you guys. Go ahead.
A plus B divided by 2H.
Is that from the card, or is that from what you remember? I don't know what you're doing over there. There's like a big hair. I can't see. Oh, you just Google it. Okay. So what does the A and B represent? Your what? Top of the bottom normally. So if a trapezoid, when we look at trapezoids, they normally go in a certain direction. Ours is to the side, right? It's the parallel sides of a trapezoid is the B1, B2, or in this case, A and B, right? So from my trapezoid, so I am going to make the trapezoid again. This is a trapezoid here. What was this down here on the left-hand side? It was 3, right? This is 3. What's this over here on the right? 1. What's my height? Huh? This one right here. Remember, this is a trapezoid that's turned sideways. So in this formula, it represents the height. It is 10. Right? Okay, there we go. So we're going to have a formula for this, but that's just the area. How do I find the volume if I know the area? Huh? Multiplied by the width, right? Or the depth in the, for this one right here. So we're going to now give it some depth. So my pool goes back this way to now have a volume. And how much did it go back this way? It goes back 5. So to find any volume, you find the area of one of the sides and multiply times the thickness, or the depth in this case. So we get one of the sides and just multiply that by 5. So my area is going to be right here. Let's see. Volume is going to be my B1 my height, which is h times my width. Now, am I dealing with the entirety? Am I dealing with the whole thing? Okay, I'm going to change the blue because I'm dealing with a certain amount of water, right? What's the height of my water that I want? 1.5, right? So 1.5 would be like right here, something like that. It doesn't go all the way up though, right? We're making the volume formula for the whole thing. We just made the volume formula. Because it's not a regular shape, is it?
But, I mean, it doesn't matter what the rest of it is above it.
We need to have a volume formula for it. So I'm trying to teach how to make these, because you're not going to have a lot of the similar ones. You're not going to have basic cubes, which is length, width, height. You're going to have something else. You're going to have weird shapes that you have to try and figure out what it is in the first place. So you're going to do like, a triangle or something times whatever depth I have on those. So it's something you have to learn how to do.
So then do we just have a derivative of?
We're not there yet. Okay? We're not there yet. So, right now, I know that this is, I want this at 1.5, right? So the blue one's 1.5, but I don't know all these values here. I know that the red is going to be 2, and this side is 10. So the red one is specific. These are our known values, right? Morning. I did, but I didn't print anything.
Okay.
So I'm a horrible person. So over here in blue, my height that I'm working with is 1.5. Do I know this value right here? Nope. So whatever value I have for that one right there, I'm going to put an X. Because I don't know that. Now what we're going to do is set this up because I don't know this height. I'm going to do this because there is a change, a rate of change. So doesn't this one change as I go this way? Because as the water keeps filling up, this X value gets bigger, doesn't it? So there is a change on that one. So in my formula, that change right there is going to be what? What is that going to represent? That's the reason why we made this formula, so we could see what it actually is. In this, the 10, right? That was supposed to be the height, right? So if it's a change in the height, that means I have a dH dt, right? Okay, so that's where a dH dt comes into play. But in this case right here, yeah, so my H is this one here. I'm going to change this one to X. So it'd be like a dx dt. And then for this problem here, because it's looking at something different. And you see why I did that. I made the formula, and now I'm looking at different parts of it here that I'm actually going, okay, I'm going to have a change here. This is changing as the height changes. So these are changing proportional to each other. They're proportional to each other. They're equal in proportion. Similar triangles. Do you guys remember similar triangles? Yeah? So similar triangles proportion would be like 2 over 3 is similar to 4 over 6. They are proportional to each other. Yes? We had to go way back into geometry for that one. If you're questioning it, please say something, because right now this is probably going to end up blowing your mind as we do this next part. Okay, I'm going to set these up. Since these are proportional, I know that 1.5 is with X, and then proportional would be 2 over 10. Why did I put X? Yeah, 3 minus 1 give me the 2 for this red triangle here. Because this height is 1, it goes 1 all the way across, and so that means that there's 2 going down that way. One more time, I'm sorry.
So X is just 7.5.
Should be, yes. But doesn't it change? So as I go through 2x equals 15, right? Yes? Okay. Now, it's asking for this one right here. Since I went through and I did all this for the entire pool, now what is it that I actually need? This goes back to what Ms. Becker was saying. Do I need the whole pool? No. I only need the blue. So what shape is right there for my volume of that? It's a triangle, right? Because at that point, we're only working with that amount. We'll work with the blue part, and it has depth. So my volume is equal to 1/2 base times height times width. It's just for this one right here, because think of this triangle, turn it sideways. Turn the triangle sideways. So that's why I did it right here. So we can see that this one's changing. I didn't want to use the same variable that we were doing to make our formula. Yeah. Yeah. Now, let's look. Does this value back here change? This one right here. So going back, does the width of the pool change? No, right here. So this is still 5, isn't it? So that means since that does not change, that makes W a constant. Since that does not change, that is a constant. I don't have to worry about doing my implicit differentiation because it's a constant, it doesn't change. What does change is, in this right here, I have a base, which is this value here. I have a height, which is this value here. So let's look to see what we have, because I have too many variables right now. So this is going to be my height. This is going to be my base, because we're ended up looking for dHdt, right? Changing the height. I'm going to call this one my height. So it's going to be, if I'm,
Height was the X.
huh?
I thought our height was the X.
I'm turning it this way now, so it actually finds it. Yes, it is going to be for this right here. This is why I'm saying this is a whole day for this one problem, because we have to make formulas for this. There's nothing like specifically, oh, throw it into the formula, find your math, there it is. We have to make a formula. So this has to be used to replace my values. So my height is changing, and in this case, my x is changing. So it would be volume equals 1/2
Wasn't X the height?
That's what it just asked. Since we're turning it sideways, we can just swap them.
Yeah.
And then can we put the 5 in for the width?
We can. So we can put that because that's not changing. And that is my, because it doesn't change.
So we should input the 1.5 for the height. Is that what we're saying our height is right now? Okay, so we can put input in 1.5 and then solve for X.
So before I get to that, Because that is changing, isn't it?
I'm trying to find it right, so I'm not telling you.
Yes, but what type of product, or what type, this would be a product rule right here, wouldn't it? Okay, too many variables. Too many variables, because I cannot do if I have 3 variables on this one. Even though I know what the dv dt is going to end up being, I would have a dx dt and a dh dt, but I know those are proportional. That my x is proportional to my height, which is same as wait, hold on. I did it backwards because my height was the 1.5. Height is 1.5.
So we use this formula, and then once x reaches 10, then we have to use the transport formula, correct?
Yes.
But we don't really care about that until we find up to
210. Yes. Now, this is where, like I said, that everyone's going to have a problem with. Do you guys agree that x and h are proportional to each other? As one changes, the other one changes also in the same similarness, right? So I could say that 10h is equal to 2x so 5h is equal to x. Joey Green. There you go. Now, what I did is I am now getting rid of which variable? I'm getting rid of the x. Volume is equal to 1/2 5h times h times 5.
Would that be 5h squared?
Huh? Yes, it will.
Technically, could it also have been x squared?
Huh?
So could it have been x squared too?
You could have, but then we would have been looking for this changing here.
All caps.
But we're only looking for this change right here, as it is 1.5. Okay, now, let's clean this up, and then I'm going to go to a new page to do all my math. So volume is equal to 25 over 2h squared. Derivative of the volume, respect to time, is 25h. What else am I missing? dH dt.
Oh,
Took a derivative. That one?
Technically, we know dv over dt.
Is
It's a different.
300 liters, right? Okay, we're gonna have a slight issue here, because what is my height?
Wait, I thought your height.
And my height, what are my units on my height?
Meters. Well, and
Do you guys see the issue here?
Oh,
What's my issue? Liters and meters, right? I gotta fix those. I gotta correct that. Okay. So just so you know, it's 1,000. So let me see. It is 1,000. So I have different units, so I have to know how to convert units. So I'm going to change this from 300 to what? Point 0.3 is equal to 25. My H value was 1.5, right? dH dt. Isn't 1.5 just 3 over 2? So 3 over 2 times 25 is 75 over 2? Yeah. Isn't 0.3 the same as 3 over 10? I want to divide by 75 over 2. Multiply by the reciprocal. So my dH dt is going to be 6. Actually, if I go times 2 over 75. What are my units? What's my height? What's my units on height? Meters. It's not talking about volume, and it's not talking about area, right? So, in this case, the height by itself, I'm only measuring it going straight up. So it's not a volume, okay? So this one's going to be a meters per minute. And as a decimal, it's like 0.006 or something like that. I don't know. 1 divided by 125. Oh, 0.008. I was off. Sorry. 0.008. So as I'm pumping water into this pool, the height of the pool is going up by 0.008 meters every minute. Anyone ever try to fill up a pool? Yeah? So it takes a very, very long time, especially if you use the guard hose. Yeah. So that seems appropriate. Now, questions. Because we did go over a lot, and there was a lot to break down just to even be able to do the problem. Go ahead.
So did you ever actually use the volume on the?
Nope. I started with the volume because I started with everything that I could use for this problem. I didn't need the width, right? Because the width ended up being a constant, right? But I started by doing the whole thing. So as I'm building my problem, I'm building a formula to try and make it. So for the volume that I was looking for, I only needed the bottom portion of it. Sometimes on the problems that you're going to use or you're going to see, you're going to have to do the whole portion. Or not just the whole portion, but above that the shallow end. So you would have to have the full volume formula, right?
Yes.
So that's why we started with that. And then we looked to see how much do we actually need. We only needed that bottom little portion, which is a little triangle. So you need to be able to create what you have. Yes?
How to get 1 over 25.
1 over 125. Okay. Are you okay with my 3 over 10 and my 75 over 2?
Yeah.
Okay. When you divide fractions, you multiply by the reciprocal, don't you?
Yeah.
Okay, so reciprocal of the bottom, so it's 3 over 10 times 2 over 75. Now, I'm going to do some reducing. You ready? 3 goes into 75 how many times? 25. 3/4 is 25, isn't it?
Yeah.
Okay, so are you okay with that reduction?
Yeah.
So I'm trying to reduce before I actually multiply to make my life easier. What about that 2? That 2, how many times 2 go into 10? What's left on top? What's left on bottom? 5 times 25. And 5 times 25 is $1.25. Other questions? No? Huh?
It's a lot.
I know it's a lot. That's why I told you at the beginning. This is probably going to be a whole day just for one problem. And I wanted to break it down slowly so we could actually say, hey, this is not just a plain and simple. You're going to have to make a formula for this and plug in what you know, what you have, and work out what you have.
The hard part is just like figuring the things down and then figuring it out. Because I mean, I think we all have the derivative part down.
Yeah. Am I 5 minutes off? I thought it rings at 9. Or 10.
Well, 5 plus 50 is 55.
Oh, it is 55. Dang it, I'm off by 5 minutes.
Can you post this, please?
I will post this.